Hey everybody, welcome back to Swift Fundamentals. Today we're diving into two crucial topics, memory management with ARC, as well as memory safety in Swift. You'll learn how Swift automatically manages memory with ARC, how to avoid retain cycles, and how Swift ensures safe memory access. Let's go ahead and dive on in. So let's go ahead and start with ARC, which stands for Automatic Reference Counting. We use this to manage memory. Each object in memory has a reference count, and when the count drops to 0, the object is deallocated. All right, I'm going to go ahead and create a new class here. I'm going to call it person. We're going to set up a name, so say let name should be a string value. I'm going to use my initializer and just use the autofill feature here. We're going to add a print statement where we're going to interpolate the name. We're going to say is being initialized, and then after the initializer we're going to create a d-init, which is going to deallocate something or deinitialize. I'm going to add a brace, and let's go ahead and print the name once again, and we're going to say is being deallocated. I'll put being up here, being, not being. All right, let's create a variable of person1. And we're going to add a colon, and we'll say that this is going to be person. We're going to use our question mark operator here, equals person name, and let's give it a name. Let's do June. So this is going to be our reference count, and that should equal 1. And then person1, let's go ahead and have them equal nil. So this will take our reference count to equal 0. The object is deallocated. Let's go ahead and run our program real quick. Cool, and we can see on the right side that we have our person, and then we have them being set to nil. And we can see down here, June is being initialized and June is being deallocated. So let's talk about the code real quick. So within our class of person, we've created a class with a name property and a custom initializer. Then we've added the deinitializer method, which will print when the object is deallocated. Here, person1 holds the reference to a person instance, and then we've set person1 to nil, which drops the reference count to 0, therefore deallocating the object. So when it's created, it's being set to the number 1, and when it's set to 0, when it's set to nil, it's being set to 0 and then deallocated. One common ARC issue is retain cycles, where two objects holding strong references to each other, preventing deallocation. Let's see how we can fix it with weak references. So I'm going to get rid of everything we have here. All right, I'm going to create a new class here. I'm going to call it owner, and I'm going to have a name, be a string. Let's go ahead and initialize that real quick, and we'll also deinitialize. And when we deinitialize this, we'll just go ahead and print that the name, so it's going to interpolate that, is being deallocated. All right, we're going to create another class here. I'm going to call it asset, and then within here, we're going to create a type. So say that this is a string. We're then going to create a weak variable of owner. And we're going to reference our owner class. We're going to put a question mark there. So this is the weak reference to owner. Let's go ahead and initialize the type. I'm actually just going to only have the string here. So I'm going to go ahead and get rid of the type. So I'm going to get rid of the owner references there. Let's also create a deinitializer here, same as we've done above. Print, reference that type is being deallocated. All right, now within our owner class, we can actually create a strong reference to asset. So underneath my let name here, I'm actually going to put a variable of asset, and I'm going to refer to that asset class. I'm going to add my question mark as well. This is going to be a strong reference to set. All right, let's see this in action. I'm going to create two different variables. I'm going to create a person of the owner, and then something to do with the asset itself. So maybe we'll do like a car or like a house or something. So let's create a variable, and we'll call this to be, I don't know, Mike, and they will be a owner. Let's go ahead and add our question mark here, equals owner, plug in the name Mike. Actually make this a lowercase down there, and we'll go ahead and set the variable of a car, and we'll set this to be an asset. Again, we'll do the same thing, asset. Go ahead and create a variable for maybe a car. Set this to be an asset. We'll use our question mark here, equals asset, and then the type. Let's have this be a car. All right, and we'll say Mike question mark dot asset equals car, then car question mark dot owner equals Mike. So this is going to say no retain cycle due to the weak reference. Okay. Now let's set Mike to equal nil, and then the car to equal nil. And let's go ahead and run our program here. All right, so we can see that we've set up everything, and then Mike and then the car will be deallocated. So essentially for the strong reference, we have the owner, which strongly references asset, our weak reference, asset weakly references owner, breaking the retain cycle. Both of these objects get deallocated and are properly deallocated when their strong references are set to nil. All right, and that's it. Today we explored how ARC manages memory in Swift, how to avoid retain cycles with weak references, and how that Swift enforces memory safety through those rules. Understanding these concepts will make your Swift code more efficient and reliable. Thank you so much for watching, and don't forget to like, subscribe, and comment. Dream big, code bigger, and we'll see you next time. Bye.